Hi everyone, today we'll be going over how I did this effect in TOUCHDESIGNER using point clouds and tops. So here I use media pipe to control the morphing, but for the sake of simplicity, we'll just use our keyboard. So if you hold down the one key on your keyboard and release, it will morph in the exact same way as the demo video. We'll also just use two, but you can use as many point clouds as you like, and you can use whatever models you like as well. So for a quick overview of the project, we are going to learn how to create an instancing network using positions and color data. We're going to set up a little system to control the particles exploding and then morphing back into place smoothly. How to make a quick little cage for the particles, and some really simple post-processing to create this really cool effect. So without further ado, let's get started. All right, so the first thing we are going to want to do is import our point cloud file. So hit tab, and then because we're using tops, select point file in, and then this way you can add your point cloud file. It's important to note that if you hit red, green, and blue, you'll have these options, but not all point cloud files have that. The general gist is for red, green, and blue, it's probably going to be either XYZ, RGB, or red, green, blue. Select one of those for these. But for today, I'm just going to copy and paste mine in because I already have them. So yeah, these don't look like the models, but that's fine. The first thing we are going to need to figure out is the sort of number problem. And what I mean by that is if you double click and then press info, you'll see that there are 403,225 pixels. For the second model, there are not that many, there are less. So why does this matter? So for instancing, we can think of it like particle number one, has sort of its position data and eventually its color data. When we morph them, we need to give it an instruction of like, hey, particle one, instead of being here, I want to move you to some other location with some other color. And that's fine. However, as soon as we get to particle 239,122, this doesn't exist. So this particle from the first model will try morphing into something that does not exist, and then you will not be able to do the effect. So the main problem we need to solve is how to make them the same size. This way, no matter what point cloud file you use, whether it's too big or too small, it will have the exact same amount of points, and we can then do this effect for however many point clouds we want. So let's first start with handling the position data. So first, we are going to want to add a point transform. This will allow us to, for example, change the scale of all the points later on. This isn't important now, but we'll get back into it in a bit. So one way we can solve the number issue is using two fit tops. So if we drag and then hit tab and then fit, what we can do is go to common, and we can set the output resolution to 2 times. What this does is it increases the resolution by 2 times. But what's important is that if you double click, you'll see that there are now over 1 million particles, way over 1 million. So we have a lot of particles. But if we go to fit again and we hit common, we can then do output resolution to limit resolution. And then I like using 800 by 800, but you might need to do less if your computer can't handle it, and you can do more if your computer can't. By doing this, now we have 640,000. So this might not seem important, but now if we copy and paste all of these, and then do like copy, paste, and make our second point cloud the input. If we look at the fit 4, it also has 640,000. So this way sort of standardizes how many points there are, so they are all consistent. So that's great. So the last thing we want to do is for fit 1, for input smoothness and viewer smoothness, select nearest pixel. And we want to do the same for the other fit. And then we want to do it for these two as well. Great. And that just helps with the particles looking really crisp later on when we render it. So now we have all of our position data sorted out. So now let's handle color. So what we are going to want to do is hit Tab and then do point file select and drag our point cloud right over it. So now it's referencing it, you can see. And then same thing, click and then do red, green, and blue. Great. So now something is going on. They're different. So we need to make this into color. And the way you do that is attach a math, and then you divide by 127. And then if we do it correctly, it should be red. There you go. And I can explain why this is in another video, but it has something to do with how color values are stored, and they're not between values 0 through 1. So you can do the same thing with the fit trick. Select both of these, Command C, Command V, or copy and paste, and then we should see 640,000 pixels, and that we do. So we do the same thing. So just copy and paste this entire network, and then drag your second point cloud to it, and then great. Once again, we should see 640,000, and that we do. So now we can set up for our switch system. So go to switch and tops, and then we need to connect the position nodes to switch, and then do one again for color. So what you can do if you're really organized is say, for example, like position, drag in, and then color, drag in, and then similarly position, butterfly, color, butterfly. And these naming conventions are completely arbitrary. They can be whatever you want. So when people tell you to, type POS, COL, it has nothing to do with syntax, at least for now. It's just for your own discretion and whatever helps you understand it. So if you wanted to, you could say, for example, like, I don't know, position, drag. That works too. But this is just a really clean and simple way of doing it. So now we are going to want to attach both of our position nodes into switch, both of our color nodes into the other switch. So now we can see in switch 1, if we press P, that we have two inputs, one for the drag and one for the butterfly, and for color, same thing. Important for both of them, we want to blend between inputs. This is because, for example, if you have values between 0 and 1, so let's say you want to morph the drag, something halfway between the drag and the butterfly. If you do blend between inputs, it will allow you to have a sort of blend, and that's what gives you that really clean morphing effect where everything switches at the same time. Great. And then we can sort of really neatly tie this up by adding a null. When I first used TOUCHDESIGNER, I didn't really understand why people use nulls, but an analogy is that you can treat them like periods in sentences. So when you write an essay, you don't have to use periods, but it allows you to discern when you finish an idea and when you're starting the next one. And that's what we're doing. We have finished creating our system for position data and color data, so we add a null. And we can name it position data and color. So that way, if we make edits in our sentence or our thoughts, then it will remain unaffected. But at least we know that's where it ends. So we'll come back to this in a bit. But just so we can sort of see what's going on, we can start setting up a really simple render setup. So go to tab, go to comp, geometry, then we see this torus. Let's get rid of that. So double click, delete that, hit tab, go to SOP, then add, and then P, and then add points. So this will make it such that when we instance, we can add points. And then we need to convert that. Convert, and then it should be from type convert to particles per point, and then particle type render as point sprites. And then we want to see it in both the render and the geo comp. So purple render, blue for display. Great. So it looks like nothing has happened, which is expected. So now let's add a camera, go to comp, then camera, light, then a render. So then go to top, render, and we still see nothing, which is expected. So now we are going to want to instance our lovely data that we prepared. So one way we can think of instancing is that, believe it or not, each pixel on their color represents a coordinate in this sort of three-dimensional space. I will get to that in another video, but you know, each pixel has its own coordinate and geographical position baked into it through the color. Same thing for the actual color. So this is the actual color that will show. Instead of me manually telling TOUCHDESIGNER, hey, I want you to put particle 2 at this XYZ coordinate, we can just reference this and reference this really simply. So we can do so by going to Geo1, go to instance, turn instancing on, and then translate op is sort of like the X, Y, and Z position, so sort of like your coordinates. So we are going to want to take our position top, drag it into translate op, and then for translate X, Y, Z, R, G, B. Now we can see we have something. And I guess it turns out when I was making these models, I didn't take away the bug one. So you can enjoy too, but at least we can see our dragon. Great. And then to add color, we go to the second tab, instance 2, go to the color mode, and drag the color top. And once again, R, G, and B. And we can see we have a red dragon. Cool. So now we can adjust the sizes of these points using material. So hit tab, go to matte, and then point sprite, and then drag it onto the geo, and then select the material, and then great. So if you go to point sprite, to change the size of these particles, you can change it here. So if you want it bigger, obviously drag it up. If you want it smaller, you just drag it down. And great. I think 0.7 looks pretty cool. So it gives that, you know what it is, but when it morphs, it's pretty obvious. So great. Now we have that. So we now need to switch between each one really cleanly. So now we will create our chop setup so we can do things like switch between them, explode the particles, and all that. So here's how we do it. So the first thing we are going to want to do is use chops. So go to tab, chop, and then keyboard in. So for keyboard in, if we select it to 1, if we hit the number 1 key and let go, it works. And we can set this to any number, so 5 as well works. You can even set it to letters. But for this video, let's just stick to 1. So when it's morphing, there are a couple of things going on. So first, the particles explode while still being a dragon for the first model. After you release the keyboard, it will switch all the coordinates, get rid of the explosion, and then cleanly morph into the second model. So we need to sort of account for that delay, or sort of those like chain of events. So the first thing we'll do is set it so that when we hit 1, we have some number that will act as how much the particles explode. So to do that, we can first use a math. So math, go to range, and then we can set the from range and the to range, two values we want to use. So what this does is, for the from range, it says, okay, from my input, this is the range of values, and I want to scale those values to this new range. So if we hit 1, the new max, instead of 1, should be, now the max is 0.37. So if we hit 1, we have that. And what I mean by scale down is, for example, this part you don't have to follow, but let's say we half it, right? So now when we click it, we get the value 0.5. Instead of the value being half of 1, it should now be half of 0.37. And if we hold 1, we can see that work. So that's what I mean by it scales the values down. Great. So instead of just it being like, okay, I hold the keyboard, it's immediately that value, we want a sort of gradient so it happens smoothly. So what we can do is use lag. And if you want smoother animations for anything, this is your go-to. So now if we hold 1, the value changes really smoothly. So we'll see here that now there are also 2 values. So what do they mean? The first one means the lag, or how long it takes to get to the value when values increase. And the second one for when it decreases. So to make this really exaggerated, let's set this to 5 and 1 and 0.1. So what this means is that it will take 5 seconds for it going from 0 to 0.37, and to go back down to 0, it's super quick. So if I hold 1, it'll take a while to get to the max value, and when I let go, it's really quick. So hold 1. As you can see, it's taking its sweet time getting to 0.37, but if we let go, it's gone immediately. So it's subtle, but it's important, because for the animation visual, we want a really slow expansion, but a really quick morph. So what we can do is play around with it, but I liked 0.7 and 0.2. Or rather, 0.5. Great. And once again, we can sort of like add a period to our plot and add a null. So now we know that this is the amplitude. And once again, this is a generic naming convention. You can name this whatever you want. You can leave it at null 1, but this just makes it such that we know, okay, this value is for the amplitude. Great. The second thing we need to do is now add a count. So we need to know that when you let go of it, it will start morphing into the next and blend into the second input. So we need a way to figure out, as this value decreases, it will count up 1. So first we do a lag for really smooth values. Once again, 0.5 to 0.2. And to do the count part, we use a count chop. So count. And then we need it to trigger on decreasing values. So set to 0.7. So this means that when the value goes from 1 to 0, right, decrease in values, when it gets below 0.7, it will count up. So if we hit 1 and we release, it counts to 1. Great. Now we only have 2 inputs, so what happens if we do it again? Now we are at 0, 1, and 2. So that's not good. So we need to clamp these values. So go to count, limit, loop min and max, and then we can do it to 1. And then reset that. So now, if we hold 1, release, and we do it again, it will go back to the first input, 0. And we just change this value for however many point clouds we have. So if we have 3 point clouds, okay. So if we have 3 point clouds, it'll be 2. So it'll go from the first input, the second input, the third input, back to the first input. Great. And then, once again, just to make it a little smoother, we add another lag, keep at these values, and then we add a null. And then what we can do is, we can name this one index, but once again, these can be named whatever you want, or however it best helps you keep track and understand what everything's doing. So now, if we wire them up, so go back to the switch, for index, you click on this little star icon, then drag it into index. You'll see it turns blue and there's an arrow, which means it's being referenced. And then similarly, we drag it. Great. So now if we hold 1, it should switch really cleanly on its way back down. It does. Great. So now we need the particles to explode. So here's how we do that. So we're gonna go back to our position network, and we're gonna add a couple of things. And that's why it's really nice to add this dot, or not dot, this null that acts like a period, because now we can edit it again. And we are going to add noise. So from the switch, drag, then tab, and then hit noise. And then we see a bunch of things happening. Once again, I can go into it in another video, but pretty much whenever these colors are different, it means the geographical position of each particle is different. So if we hook it up, we're gonna get something that does not look like a butterfly, which is good. And we can control it. So undo that. And eventually we are going to add this noise back to our original position. So think of it as we are adding distortion to our original position data. So the first thing we're going to want to do is hit P, pull up the menu, output, set it to only noise. Great. And then for these values, we can make it anything we want, so please experiment, but these are the ones that I used for the project. Yeah, and then monochrome off, and then put into the second one as well. And this makes it such that they're more like lines. Great, so we can kind of see it's working, but how do we make it if I hit 1, go, so there's no noise and it morphs cleanly. We're gonna wanna look at amplitude. So going back to our chop network, go to amp, make it active, drag it to amplitude, chop reference, and great. Now we see our particle. If we hold 1, we'll see that the amplitude will change as well, right? So it's the first part of the chop setup. And when we release it, it will count the position. So it will switch to the new position while also the amplitude goes down. So, yeah. So great. We hold, let go, it will change index and also get rid of this noise. Yeah. So now we have a really clean morphing effect. So now we are going to want to sort of change the perspective of the dragon. And we can do this by going to our point transform from much earlier on. So I'm gonna go back to this, and then we can just click it so we can see it in the background. And then one other thing is let's just select everything, or rather click render, select everything, go to common, and then we just want everything to look really clean. So viewer smoothness to nearest pixel kind of helps out there, and then pixel format. This just kind of makes it like higher render or lower render, so make it 32-bit float. Great. So now we have a sort of like a wider color range. And great. So we do it again. Colors are much more vibrant, and everything's a lot more crisp and good. So for this one, we want to kind of like rotate it, right? So it's like this one you can just like kind of play around. So it's like 90, maybe like another 90. And then this one, I don't have like a perfect science to it, but honestly, this one's pretty cool. So -40, great. And that kind of brings it in there, great. And for the dragon, it's also pretty cool actually. Maybe I should just use this instead, but you get the gist. Just play around with values until you get something that you like. Honestly, just leave it at that. Nice. And then we are going to want to make it spin. So I want the box to have only the lines. So hit tab, material, and then go to wireframe, and then drag it on. So now we have lines, and then we can go to wireframe mode, topology. Another way you can do it is tab, line, and then drag it on here. And this way you control things like how wide it is, how thin it is, and a lot more cool things. But wireframe is easy for now. Okay, and then for the balls, we don't want there to be shading, at least for now, so we can use constant, drag it on, and then now they don't have any sort of reflections. And then I kind of want the box to be bigger, so we can go like 1.5. And the sphere, I want them to be a bit smaller, so 0.03. Nice. And then for the geo, we can make this a bit smaller, so like 0.8. And then, yeah, so now it's contained in the box. We hit 1. Great. So now our models are inside this rotating box. And to add a background, we can do insert operator, transform, and then set comp over background color and the alpha to 1. And then, right. Great. Another way you can do this is like you do a constant, and then this will sort of be your background. Then you can change to the resolution of your project, then use an over, make your effect over this background, and then connect it that way. And we can make this black. Great. So yeah, so now we have a morphing particle effect. If you want to go more into the post-processing effects, the file will be in my Patreon, which is in the bio. But yeah, so with a couple of nodes and a little bit of chopped magic, we have created this really cool effect. So you can do a lot of things too. So for example, if you want these particles to move, you can go to noise, noise to 4D, and then transform, like translate 4D abs time dot seconds. So I can do some like really exaggerated number, but now it will move while that happens. Maybe make it a bit more chill. Oh, maybe more chill. Nice. Now it's like moving really subtly. But yeah, so I hope you enjoyed this tutorial. I hope it's the first of many, and please enjoy. Thank you so much.